Okay friends, welcome to part 3 of my video presentation on database design. In this part we will talk about something called resolving non-specific or many-to-many relationships. Now this is what non-specific or many-to-many relationships are all about. Sometimes when you model a database, you have a situation where you have two entities, such as here you have a student entity and curriculum or major entity. And the relationship between those two entities has many on both sides. So that's why it's called the so-called many-to-many relationship. So what it means that one curriculum or one major is associated with many students because many students can be enrolled in one specific major or in one specific curriculum or program of a study. Now the same thing on this side. One student can be associated at the minimum with one, at the maximum 2, 3 or many majors or study programs, because in most universities students are allowed to have double major. So that's why it's the so-called many-to-many relationship, because you have many on both sides. Okay. The thing is, you cannot have a many-to-many relationship. The reason you cannot have a many-to-many relationship in your database is that it's impossible or it's hard to implement this kind of relationship without violating the integrity, the structure of the database. So once again, you cannot have a many-to-many relationship in your database model. So you cannot have a non-specific relationship. So the question becomes, if you do have this situation, what do you do? Now, a short answer to this question is that you address this problem by resolving this many-to-many relationship. Now, how do you resolve it? Well, you resolve it by introducing something in between, by introducing an associative entity in between. Okay? So this is another illustration of the same principle. So you have an entity called order and you have an entity called product. Now one order can be at the minimum for one, at the maximum for many products. And one product can be ordered at the minimum 0 times, at the maximum many times. So there is a many-to-many relationship between orders and products. So how do you resolve it? Well, you resolve it by creating an associative entity called ordered product. And this associative entity transforms this many-to-many relationship into a series into two one-to-many relationships. Now, what is an associative entity? I'll go back to this slide where the associative entity concept was first introduced. Well, there are a couple of things that we need to say about associative entities. Well, first of all, an associative entity is an entity that links other entities. So in this case we have an associative entity called assignment, and it links project, employee and location together. Okay. The other thing worth mentioning is that the reason we know that this entity, assignment, is an associative entity and that it links those three entities together is not because of this sign. I mean, although this this notation used here helps us to see that this is an associative entity. We see that this is an associative entity linking the following three entities because this entity, assignment, has the so-called compound primary key. Now, if you remember the definition, compound primary key means this key consists of several parts. Now, in this case, our primary key, assignment ID, consists of 3 parts: project number, employee ID, and location number. And each of those parts comes from another entity. More specifically, each of those components of this compound primary key called assignment ID is a primary key from another entity. So this is how we know that this is an associative entity. So once again, we resolve a many-to-many relationship by introducing an associative entity that would transform this many-to-many relationship into a series of one-to-many relationships. Okay, so that's the solution to the problem of non-specific or many-to-many relationship. Now, I'll show you how this works at the table level. I think once you do it at the table level, it will make a lot of sense. But before I do that, I would like to kind of talk a little bit more about associative entities. I told you what associative entities are at the technical level. So at the technical level, it's an entity that links 2 or more entities together. But what are associative entities from that kind of pragmatic or business standpoint? It's hard to explain what associative entities are because it's hard. Sometimes it's hard to find like a real-world analogy of this entity. So in our case, here for those two entities, we understand what an order is. We understand what a product is because there are some real-world analogies to product and order. Now, the only real-world analogy that I can come up with for an associative entity would be something like accounting general ledger or general ledger in accounting. Now, if you ever took accounting course, or if you ever worked in accounting, you probably remember that general ledger basically means like a book. In the old days it was a book. Nowadays it's it's something that is implemented with the help of IT, but it's basically some kind of record, okay, where all accounting transactions are recorded. So whenever there is any kind of financial transaction at a company, this transaction is recorded into this general ledger. And once it's recorded into this general ledger, then it can be posted to specific accounts. For example, if it's something related to accounts receivables, this entry from general ledger is posted to account receivables and to cash, to appropriate account. But it's like a general record, okay, general record. So that's the only analogy I can give you. You can think of an associative entity as some kind of general ledger where data is recorded whenever the two entities that are being linked come into some kind of transaction. So whenever a product is ordered, then you make an entry here in the ordered product associative entity. Okay? So that's the only real-world analogy I can give you. It's some kind of ledger, some kind of record that is used to record transactions of the two entities that are being linked. Okay? Now I'll show you how associative entities work at the table level. So hopefully, once you see like some technical details, it will make more sense. So for that, I will use an Excel sheet. So here, in this example, we have two entities. One entity is called student, and the other entity is called major. Now, for simplicity, both entities, they only have two attributes. So for student, we have student ID and student name. That's it. But of course, we can add like a lot of other attributes to the student entity. For the major entity, we also have only two attributes, major ID and major name. Okay. Now, in both entities, the first attribute is the primary key. So we'll mark it here in the table as well. Now, as you saw in this presentation example, the relationship between student and major is a many-to-many relationship because one student is associated with, at the minimum, with one major, at the maximum many majors, and one major can be populated, at the minimum with one student, or zero students if it's new a major, nobody has declared that major yet, at the maximum many students. So it's a many-to-many relationship. Okay. So once again, we cannot have a many-to-many relationship in our database model. So the question becomes, what do we do? Okay, so once again, you resolve this many-to-many relationship by introducing an associative entity in between. Okay. Now, I will create a table that would represent that associative entity linking students and majors together. And I will call this entity, I will call it student major declaration. Now there's no like specific naming convention for this entity. I will just use this name because I think it reflects properly this transaction between students and majors. So remember, I gave you like this real world analogy. I told you that an associative entity that links two entities together is basically like a general ledger, like a journal where transactions between those two entities are recorded once they happen, right? So that's why I think this name, reflects the fact that this is a transaction record of students declaring majors. Okay. Now, also remember, I told you that associative entity, they have the so-called compound key consisting of several parts, and each part is the primary key from the entity that this entity is that this entity is linking, right? So student major declaration would be the name of our associative entity. Now this entity will have a compound primary key, so I'll merge this two cells. Now the name of that compound attribute would be student major declaration ID, let's say, and that would be our primary key. Now this primary key will consist of two parts. The first part will be student ID, and we'll use this dot notation. And the second part will be major ID from here. Okay, and we'll use this dot notation to show that those are the two parts of student major declaration ID primary key. Okay, so that will be our compound primary key. I'll put a table around it. So in a way, this is like one attribute. Okay, but this attribute, this primary key, is a compound attribute because it consists of two parts. And then we'll just add one more attribute. Let's say it will be student major declaration date. So we'll just keep track of dates. And now I'll delete this extra attribute because just for simplicity purposes. Okay, and I'll move this closer. So this is another attribute. So this is the table that would represent this associative entity called student declaration. And once again, this entity links the student entity with major entity. So in that case, this is how records will be added to this associative entity. Let's say on September 4th, somebody named Bill, student named Bill with student ID 1, decides to declare MIS as his major. Okay, in that case, we'll add 1, which is student ID of Bill. Right? We'll also add here 1, which is MIS major code, and then we'll put date here, which is, let's say, September 4th. That's what I said, right? Okay, so you see there was a transaction between Bill and between MIS. So in other words, there was a transaction between student entity and major entity, and this transaction has been recorded here. So let's say later on, Bill, who has student ID 1, decides to declare CIS as his second major, right? So we'll put it here, and that, let's say, happens on the same date but 1 year later. Okay. Then let's say Lisa, who has student ID of 3, decides to declare CIS as her major. So we'll put 2 here, and that happens on October 4th. So we record the date here. Okay. And then let's say Amy, student ID 4, declares accounting. Accounting has ID 3 as her major on the same date. Okay, so this is how things work at the table level with associative entity. Something along those lines. Again, I'm not going to explain to you why you cannot implement many-to-many relationship, because it's similar to this previous example that I gave you. Once you have a many-to-many relationship, it means that you'll have to add more than one foreign key into one cell, and that would violate the integrity of the database or of this specific table. So that's why you need to resolve it by creating an associative entity. So associative entity would link those two entities together by recording those transactions, and you won't have to change any structure of any of those tables. Okay. So this is an example of how to resolve a many-to-many relationship, and this concludes part 3 of our video presentation. Thank you for listening.